This is another type of visualization, and what you're seeing here, that's the same artery that we saw before, and the arrows represent little spots, or you can imagine in both of these cases, you have your simulation of blood flowing through, and you put little, stand over a river, you drop leaves in the river, and you see the leaves going downstream, and you can see how the water's moving by watching those leaves. Same thing. I'm artificially putting, you can think of it as leaves in a river, but little particles into the blood, and I'm following how they move through a patient's heart to understand what's happening. So those are what the arrows are. And then the streamlines, which you can see on the left, each of those lines has followed a path of one particle going through the blood. And so with these kinds of visualizations, the doctors are able to look and figure out where there might be problems. Does a person have heart disease? How scared should we be for their risk of a heart attack? So this is the kind of newest stuff I have going. There's an example. You can actually see some nice little turbulent features and some curling, and the blood kind of goes in a helix. It kind of twists around, bends, kind of behaves like you would have a river. So those are some hot off-the-press images. And at this point, in lieu of the time, these are just some URLs and information. I'm also up in the Career Expo. Then you can find me, and I have some 3D stuff and handouts and more information, but this just gives you a taste of what I do. And if there's any questions, I think there's some time for a few questions.
I mean, do you see a future where someone's going to be able to go in, get scanned, and you're going to be able to run a simulation on them?
Yeah. So the hope for the hemodynamics project, this is our hope, quite literally, is to be able to put in hospitals a cart. And on the cart, put a computer. Honestly, take a PlayStation. PlayStations are fabulous computers. The chips in there are better than most supercomputers nowadays. So really take a PlayStation, change the hardware just a teeny bit, put the simulation on there. The doctor comes in with a little CD or a flash drive. They put the patient's medical imaging data in. The simulation runs in the order of a few minutes, and then pops up on the screen one of those 3D images for the doctors to, in the patient's room, rotate and decide what procedures to do next, like whether they need a stent or whether they need to go on different heart medications or whether they ultimately need surgery. So our hope is, and there are some corporate sponsors already interested in this, to have a tool like that. And it would be really revolutionary to have this kind of thing in hospitals to help the doctors with the diagnosis. So, yes?
Is all of your stuff still in research or has been implemented in real life?
Say that again, it was a little hard to hear.
Is all of the stuff that you do, is it still in research or is it already being used?
On the astronomy side, it's being used, meaning we've taken one of the medical imaging tools and we've converted it and built add-ons so astronomers can use it with their data, and we have a whole user base out there of people using this for real astronomy research. And my group and I have published multiple papers now with new scientific results as a result of using the 3D visualization. So the astronomy side of things is a lot more developed. It's in practice. Other astronomers, other than the people initially in my group, are using it. The medical side of things is still hot off the press, very, very new. So that is to be seen and to be determined if we can get that properly put into clinical application. Hopefully, that's what we're hoping. Yeah.
This interdisciplinary medicine research, are you pretty much the beginning of this, or is this something that's been going on for a while? Because this is something new to me, all different.
Yeah, so I was at the beginning of this, meaning it was my trying to push and come up with the cool undergraduate thesis, and I honestly thought this was just going to be a fun paper. I had no idea that I'd really stumbled upon the gold mine here. I had no idea at the time that this really was going to be changing the field and changing how astronomers look at data. And it took me and knowing certain people like the astronomy and medical people and bringing everyone together to get something like this working. But again, the sort of interdisciplinary thing is becoming a little more common, and a lot of it has to do with sharing money, to to be honest. Why reinvent the wheel when someone else has already developed it? But then again, it's the let's share knowledge and let's help each other out thing. So in this particular instance, this was a very new, no one had done this before, setup. But the general sort of model for how this happens is happening more and more. So, yeah.
Just again, thinking about the interdisciplinary, since science isn't always taught that way. Do you have any thoughts for people who are interested in science who are in middle school or high school now, or their teachers about how you could do that, rather than have just the way we do it now?
You mean instead of having students take just like biology, chemistry, do each one? I think it would be wonderful if teachers were more willing. If you want to know the truth, here's a fun interdisciplinary thing. I got interested in astronomy through my high school 9th grade history teacher. If it had not been for a history project where we were assigned to research a figure from the Renaissance or Enlightenment and do a whole research project on them, I was given Isaac Newton. If I'd never researched and done history of science research on Isaac Newton, I would have never sort of gone down the path I did. And I was lucky. My high school's curriculum is very interdisciplinary. Their whole curriculum is set up to be interdisciplinary. And I'd love to see more middle and junior high and high schools do that kind of thing. I think it's really important to see, not just in the sciences, but in all the subjects you study, how everything relates to each other. Even for my research now, I did tons of art classes and design classes and photography, and I've later had to use all those design skills in my own science imaging research. I go back to my high school even now, and it's like, oh my gosh, thank you for teaching me all my art and drawing, because now it helps me in my research. So in particular in the sciences, I'd love to see more science curricula where they can show the students that what they learn in one area is really useful somewhere else and can be shared knowledge. So, but other than a few instances, I don't see that happening widespread. Yeah. Any other questions? No? Okay, well, I'm going to be upstairs in the Career Expo if you want to come find me, and I have more movies and fun stuff on my computer. So thanks.